Circles. A line forming a closed loop, every point on which is a fixed distance from a center point, is called a circle. Circle could also be defined as the set of all points equidistant from the center. The length of any chord passing through the center is diameter. It is twice the radius. Circumference is the distance around the circle. The area, strictly speaking, a circle is a line and so has no area. What is actually meant is the area of the region enclosed by the circle. Chord is a line segment linking any two points on a circle. Tangent is a line passing a circle and touching it at just one point. The tangent line is always at the 90-degree angle to the radius of the circle. Secant is a line that intersects a circle at 2 points. Pi in any circle, if you divide the circumference, distance around the circle, by its diameter, distance across the circle, you always get the same number. The number is called pi and it's approximately 3.142. A circle is the shape with the largest area for a given length of perimeter. It has the highest area to length ratio when compared to other geometric figures such as triangles or rectangles. All circles are similar. To form a unique circle, it needs to have 3 points which are not on the same line. Given radius r by a circle can be expressed as area is equal to pi r square, where r is the radius of the circle. If you know diameter d of a circle, the area can be found using the formula area is equal to pi d square by 4. If you know the circumference c of a circle, the area can be found using the formula area equal to c square by 4 pi. The semicircle is half a circle or a closed shape consisting of half a circle and the diameter of the circle. The area of a semicircle is half the area of the circle for which it is made. Area is equal to pi r square by 2. The perimeter of a semicircle is not half the perimeter of a circle. From the figure above, you can see that the perimeter is the curved part, which is half the circle, plus the diameter line across the bottom. So the formula for the perimeter of a semicircle is perimeter is equal to pi r plus 2r is equal to r into pi plus 2. The angle inscribed in a semicircle is always 90 degrees. Any diameter of a circle subtends a right angle to any point on the circle. No matter where the point is, the triangle formed with the diameter is always a right triangle. Chord is a line that links two points on a circle or curve. A diameter is a chord that contains the center of the circle. Below is a formula for the length of a chord. If you know the radius and the perpendicular distance from the chord to the circle center. This is a simple application of Pythagoras theorem. So length is equal to 2 into square root of r square minus d square, where r is the radius of the circle, d is the perpendicular distance from the chord to the circle center. In a circle, a radius perpendicular to a chord bisects the chord. Conversely, in a circle, a radius that bisects a chord is perpendicular to the chord, or in a circle, the perpendicular bisector of a chord passes through the center of the circle. Angles in a circle. An inscribed angle in an angle ABC formed by points A, B and C on the circle circumference. Given 2 points A and C, lines from them to a third point B from the inscribed angle is constant. It only depends on the position of the other 2 points. If you know the length of the minor arc and radius, and if the length is L, minor arc length is L, you will have the inscribed angle is equal to 90 L 9, so this is L, and this inscribed angle would be 90 L by pi r. A central angle is an angle A with endpoints located on circle circumference and vertex O located at the circle center. A central angle is in a circle determines an arc AC. So the central angle theorem states that the measure of inscribed angle is always half the measure of the central angle. An inscribed angle is exactly half the corresponding central angle. Hence, all inscribed angles that subtend the same arc are equal. Angles inscribed on the arc are supplementary. In particular, every inscribed angle that subtends a diameter is a right angle, since the central angle is 180 degrees. Arcs and sectors. A portion of the circumference of a circle is given 2 points on a circle. The minor arc is the shortest arc linking them. The major arc is the longest. On the gmat, we usually assume the minor arc length. The formula the arc measure is L is equal to 2 pi r into C by 360, where C is the central angle of the arc in degrees. Recall that 2 pi r is the circumference of the whole circle, so the formula simply reduces this by the ratio of the arc angle to a full angle 360. By transposing the above formula, you solve for the radius, central angle, or arc length if you know any two of them. Sector is the area enclosed by two radii of a circle and their intercepted arc, a pie-shaped part of a circle. Area of a sector is given by the formula area equal to pi r square into C by 360, where C is the central angle in degrees. What this formula is doing is taking the area of the whole circle and then taking a fraction of that depending on the central angle of the sector. So, for example, if the central angle was 90 degrees, then the sector would have an area equal to 1/4 of the whole circle. Power of a point theorem. Given circle O, point P is not on the circle and a line through P intersecting the circle in 2 points. The product of the length from P to the first point of intersection and the length from P to the second point of intersection is constant for any choice of a line through P that intersects the circle. This constant is called the power of point P. If P is outside the circle, PA into PD is equal to PC into PB is equal to constant. This becomes the theorem we know as the theorem of intersecting secants. If P is inside the circle, PA into PD is equal to PC into PB equal to constant. This becomes the theorem we know as the theorem of intersecting chords. Tangent secant. Should one of the lines be tangent to the circle, point A will coincide with point D, and the theorem still applies. PA into PD is equal to PC into PB is equal to constant. PA square is equal to PC into PB is equal to constant. This becomes the theorem we know as the theorem of secant tangent theorem. Two tangents. Should both of the lines be tangents to the circle, point A coincides with point D, point C coincides with point B, and the theorem still applies. So PA into PD is equal to PC into PB is equal to constant. PA square is equal to PC square. PA is equal to PC.